Right now, there are millions of rocky objects silently flying through our solar system at speeds faster than a bullet. Some are smaller than a car, some are bigger than a country, and a few of them are on a very, very long list that scientists check every single day, just to make sure none of them are headed our way. These are asteroids, comets, and the other flying debris of our solar system. And they're way stranger and way more important than most people realize. Let's get into it. First, let's clear something up. Asteroids are not just space rocks in the boring sense. They're leftovers, literally. When our solar system formed about 4.6 billion years ago, a swirling cloud of gas and dust collapsed inward, and most of that material clumped together into the sun and planets. But not all of it. Some material never got pulled into a planet. It just kept orbiting, in chunks ranging from pebble-sized to hundreds of miles across. Asteroids are essentially the building blocks of planets that never finished the job. Which means when scientists study an asteroid up close, they're not just looking at a rock. They're looking at a frozen snapshot of what our solar system looked like billions of years ago, before Earth even existed. Most asteroids live in one specific neighborhood, the asteroid belt, a wide ring of debris sitting between the orbits of Mars and Jupiter. Here's something that surprises a lot of people. Despite how it's drawn in movies, the asteroid belt is not a dense, ship-destroying obstacle course. It's mostly empty space. If you stood on one asteroid, the next one would typically be hundreds of thousands of miles away. Spacecraft have flown straight through the belt multiple times without even needing to dodge anything. The belt contains an estimated 1 to 2 million asteroids, larger than half a mile wide, plus millions more smaller ones. But if you combined the mass of every single object in the entire asteroid belt, it would still only add up to about 4% of the mass of our moon. It's less a wall of rocks and more a very, very thin scattering of debris across a massive volume of space. The largest object in the asteroid belt is actually big enough to break its own category. It's called Ceres, and it's so massive, about 590 miles across, that its own gravity pulled it into a roughly spherical shape, which earned it a special title, dwarf planet. Ceres makes up about a third of the total mass of the entire asteroid belt, all by itself. And in 2015, the Dawn spacecraft discovered something unexpected hiding there. Bright spots inside a crater that turned out to be deposits of sodium carbonate, a salt likely left behind by water that once seeped up from beneath the surface. Ceres might still have liquid water hidden under its crust today. So, technically, one of the most water-rich objects we know of in the inner solar system is sitting in the middle of what we call the asteroid belt. Now, asteroids often get lumped together with comets, but they're genuinely different objects. Asteroids are mostly rock and metal. Comets are more like dirty snowballs, mixtures of ice, dust, and frozen gases. Most comets spend their lives far out in the cold, distant edges of the solar system. But occasionally, gravity nudges one onto a path that brings it swinging in close to the sun. As it approaches, the sun's heat starts vaporizing the ice on its surface, releasing gas and dust that forms a glowing cloud around the comet called a coma, and that unmistakable tail, which can stretch for millions of miles. A comet's tail doesn't trail behind it like a streamer on a car. It always points away from the sun, no matter which direction the comet is actually traveling. That's because the tail isn't caused by motion. It's caused by solar wind and radiation, physically pushing the gas and dust away from the sun. This is where things get a little more serious. Scientists track a specific category of objects called near-Earth objects, or NEOs. Asteroids and comets whose orbits bring them within roughly 30 million miles of Earth's orbit. As of now, astronomers have identified tens of thousands of these objects, and they're cataloging more every year, using dedicated survey telescopes, scanning the sky every single night. Most NEOs are small and harmless, but a small number are large enough and close enough to be classified as potentially hazardous, meaning their orbit could, over a long enough timeline, eventually intersect with Earth's. An asteroid, roughly 1 kilometer wide, large enough to cause global consequences if it struck Earth, hits our planet on average only about once every several 100,000 years. Smaller, regional damage-sized impacts are more frequent but still rare on a human timescale. We're not living under imminent threat, but the reason these telescopes exist is to make sure that if something big ever is headed our way, we'd actually know decades in advance, instead of finding out the hard way. In 2022, humanity did something that used to only happen in disaster movies. We deliberately crashed a spacecraft into an asteroid on purpose, just to see if we could change its path. The mission was called DART, and its target was a small asteroid moonlet called Dimorphos, which orbits a larger asteroid named Didymos. Neither object posed any threat to Earth. This was purely a test. The spacecraft slammed into Dimorphos at roughly 14,000 miles per hour, and the impact successfully shortened its orbit around Didymos by about 32 minutes. That might sound small, but it proved something enormous. We now have actual, tested evidence that humanity could nudge a dangerous asteroid off a collision course, given enough advance warning. It's one of the first real planetary defense experiments in human history, and it worked. Quick vocabulary fix, because almost everyone mixes these up. A meteoroid is a small chunk of rock or debris floating through space, usually a fragment from an asteroid or comet. When that meteoroid enters Earth's atmosphere and burns up, creating a streak of light, it's called a meteor, what most people call a shooting star. If any piece of it actually survives the trip and lands on Earth's surface, that surviving chunk is called a meteorite. Most meteor showers, like the Perseids or Geminids that light up the sky every year, happen when Earth passes through the trail of dust and debris left behind by a comet's orbit. We're not getting hit by the comet itself. We're flying through the dusty trail it left behind, sometimes thousands of years ago, and burning up countless tiny pieces of it every single night during the shower. So the next time you see a shooting star or hear about an asteroid passing by in the news, remember, you're watching the leftover building blocks of our entire solar system drifting through space on timelines that started billions of years before any of us existed. Most of them are harmless. A few are worth watching closely. And, thanks to missions like DART, we're no longer just hoping nothing big ever comes our way. We're actually preparing for it. If you learned something new, let me know in the comments which one surprised you most, and I'll see you in the next one.